There are a number of ways that you can validate data and a number of places that you will validate data. And in this section we're going to look at 3 of them. When the user closes the form, we want to be able to determine if changes have been made, and if they have, we want to prompt the user to save the changes. Then we want to see how to validate data in a particular form. So the user enters data, we're going to validate it right there. And then we also want to be able to validate at the data level. So we want to see how we can add validation to the data set. Your data entry forms will typically have a save button. So if the user makes changes and wants to save the data, the user can click the save button. But it's possible the user will make some changes and then close the form without clicking the save button. So we can use the form's form closing event to trap for that. We can check for changes in there and then prompt the user to save the data. How do you know if changes were made? Well, you can use the getChanges method of the data table class. And that's going to return a copy of the table that contains only the rows with changes in them. If you call getChanges and nothing comes back, then there were no changes. And then you can decide whether you just want to see if any changes were made, or if you actually want to see what the changes were, you can inspect that copy of the table. You can validate data at the form level. So you can use the validating event handler of a control to see if the user has entered valid data. So you might have a rule that says no product price can be less than 0. So in the validating event handler of that price text box, you could check right there and then if the user has entered a price less than 0. If they have, you can pop up a message box and then use the cancel property of the cancel event args class to not let the user leave the text box until they've entered valid data. So let's go see an example of using these 2 techniques to determine if the user made changes and to validate data at the form level. I have the completed version of the data binding techniques sample application open now in Visual Studio, and it's the finished versions of what I've built from hand in the previous 2 sections with a couple additional forms. And these forms show 2 different ways to do data validation. So let's run this, and I'm going to select Form Level Data Validation. And this brings up a simple version of the products form, and there are a couple of things that we want to do in this form. First is we want to be able to detect whether the user has made changes and didn't save them, and then the second is we want to do some validation. So let's say we have a rule that the price can't be less than 0. We're not going to pay people to take our products from us. So I'll enter -5 for the unit price and attempt to tab off this. And I have code in the validating event handler of this price text box to ensure that the price has to be greater than 0. So eventually, I want to check to see if the price is less than or equal to 0. But the first thing I want to do is find out if the user actually entered a number into that text box. So if the user entered nothing, so if unit price text box.text is equal empty string, or the user didn't enter a decimal number, then I'm going to say please enter a price. And the way I check to see if the user entered a decimal is I'm going to call the decimal.tryParse method. And I'm going to pass in what the user entered and, as an output parameter, a decimal. So I'll create real DEC as a decimal. I'm going to pass that to tryParse, and then if what the user entered is the same data type as real dec, which is a decimal, then decimal.tryParse returns true. Otherwise, it returns false. So I know that the user entered -5, which is in fact a decimal, and so now I can come down here, convert that to a decimal, and if it's less than 0, I'm going to display a message and then set the cancel property of E to true. Now E is an instance of the cancel event args class, and if I set E.cancel to true, then the user cannot exit this text box. So I display price must be higher than 0, and we're still in here. Now if I enter text, then this decimal.tryParse will return false, and the user is going to be instructed, please enter a price, and e.cancel returns false. Only if the user enters a decimal greater than 0 am I going to be allowed off that field. The next thing I want to do is trap to see if the user made changes for this product. So let's set the units on order to 20. And now let's try and close the form. In the form's form closing event method, the first thing I want to do is validate data. So I'm going to call this method I wrote called validate data. Let's step into that. And that's first going to call the validate method of the form. And what that will do is validate the last control the user was in. Because if the user types something in a control and doesn't tab off it but goes straight to the close button, then the form hasn't had the opportunity to validate what the user entered. So this .validate will validate that last control the user was in. And then we're going to call the endEdit method of the product's binding source, which will take all of the pending changes and write them to the product's data table. And if that control is validated and the endEdit works, then we'll return true. Otherwise, invalid data has been entered, and the user will be asked, do you want to cancel your edits? If yes, then we'll call the cancelEdit method of the binding source to cancel all of the pending changes, and this validate data method returns false. So let's run this. We're going to validate the current control. We're going to try and end edits. Now, if the user's entered invalid data, this will throw an exception. But so far, all of the data entered is valid, and so we're going to return true. Okay, so if the call to validate data works, now we want to know if the user's made changes. So I'm going to call the getChanges method of the products table, and that will return a copy of the products table containing only rows in which changes were made. If that's null, then no changes were made and we move on. If it's not null, which it isn't, then I'm going to ask the user, do you want to save your changes? If the user says cancel, then we're going to go back to the form. If the user says no, then we'll exit the form without saving changes. If the user says yes, then we'll call the save changes method in this form. And the save changes is going to do some additional row-level validation. Because it turns out that any product that costs more than $25 cannot have a reorder level higher than 100. Okay, so we're going to check that. We want to see if the reorder level, if the user entered something in the reorder level. If they did, then we're going to check that rule. And if that's valid, then we'll call the update all method on the table adapter manager and save all the changes. And the form is closed. Okay, now we'll go back in. Let's set the price of this product to 100 and the reorder level. That's a valid price. Let me remove this breakpoint. That's a valid price. Let's set the reorder level to 10,000, and now I'll click Save. And again, we're going to validate the data, which should work. So now we'll check this rule. Products that cost more than $25 cannot have their reorder level greater than 100. And for this product, we have failed that rule. So we're going to display this message, and then the save changes method is going to return false, and therefore we're not going to call the update all. We're still on the form. Now if we decide to close the form, we still know changes have been saved, I'll click cancel and we'll stay in the form. Let's remove this breakpoint. Or I can just decide, you know what, I don't want to save my changes. We'll close the form. Changes aren't saved. So those are some techniques you can use to validate data in a form. We've detected if the user has made changes. We've validated the unit price at the point where the user enters the unit price. And we're also enforcing some row-level rules and validating when the user attempts to save a product record. We just saw how to validate data at the form level. And there's pros and cons to this approach. One nice thing about this approach is that your validation is as close to the data entry as it can get. So this form contains not only the controls to enter and modify data, but also the code to enforce rules. The downside is that this code is contained in the form, and therefore it's not very reusable. If there are multiple places in an application where the user can work with the same data, then you're going to have to duplicate this code in multiple places. So an alternative is to attach the validation code to the dataset, and you can use the dataset designer for that. So you can ask yourself, are you validating what the user enters into a control, or are you validating the data they enter? And if it's the data, then you can move that validation to the level of the data itself, and therefore put it in the dataset. And to do that, you can use several events of the data table class. The table new row event occurs when the user adds a row to a table. And this would be a great place to enter default values. So in the order details table, the discount defaults to 0, or in the products table, discontinued defaults to false. You can use the column changing event, and that occurs when data in a column has been updated. So this would be a good place to put the validation for the unit price. The unit price can't be equal to or less than 0. We could put that in the column changing event. Row changing occurs when a row in a table changes. That would be a good place to put our rule that products that cost more than $25 have to have a reorder level less than 100. Now, how do you know if the user entered invalid data? Well, each row in a data table has a row error property. And you can then call the has errors property of the table to determine if there are rows that have errors in them, and then you can use that row error property to display to the user what the error actually is. So let's go back to demo and let's see how to move the validation code we just looked at out of the form and into the data set. I'm back in the completed version of the Data Binding Techniques project, and let's take a look at Data Validation 2. This is the second version of the data validation form. So it's the same form that we looked at in the previous demo, but this time notice that there is no code in here to do the actual validation. There's no code in here to check the unit price. There's no code in here to check the unit price against the reorder level. All of that code has been moved into the data set. So I'll double-click Northwind Dataset, bring up the Dataset Designer. And there are a couple of ways that you can add code into the dataset. You can double-click a table, and you can right-click and choose View Code, and that brings you into northwinddataset.cs. Now the dataset itself is defined in northwinddataset.designer.cs. northwinddataset.cs will include code I write. The Northwind Dataset class is defined both in this file and northwinddataset.designer, and that's why it's a partial class. The partial class feature lets you split the definition of a class across multiple files. So that's why Northwind Dataset is a partial class and Products Data Table is a partial class. And so what I'm doing here is I'm taking advantage of events on the Products Data Table. So I could select Products Data Table from here, and I can see the various events that are available to me, and then I can write code. So in the begin init of the data table, I hook up the column changing, products row changing, and table new row events. Don't forget to write that code, because if you don't write that, then the events don't actually get hooked up. Okay, so the column changing event occurs when you change data in a column in the products table. And E is an instance of the data column change eventargs class. E.column refers to the column, and so E.column.column name is the name of the column. So when any column in that products table changes, I'm going to check, is it the unit price column? Because if it is, I want to validate what the user entered. Well, what did the user enter? Well, E.proposed value represents what the user entered. I'll convert that to a decimal, and if it's less than 0, I'm going to set the column error for that column in that row. E.row represents the row I'm on. E.column represents the column I'm working with, which is unit price. And so I'll set the column error for the unit price column to please enter a price greater than 0. If the unit price is greater than 0, then I'll empty out that column error. The products row changing event occurs when any row in that table changes. And so what I want to do is I want to compare the unit price and the reorder level and enforce the rule that if the price is greater than 25, reorder must be less than 100. Well, E is an instance of products row change event, and E.row represents this row. So I'll take the unit price in this row, and if that's greater than 25, and also the reorder level in that row is greater than 100, then I'm going to set the row error property of that row to this error message. Otherwise, I'll clear out the errors for that row. And the outer if says don't bother validating deleted records. So if E.row.rowState is not equal to data_row_state.deleted, then do the validation. And then finally, the table new row event occurs when I add a new row. And what I want to do here is set the discontinued column to false, because by default, products when they're added are not discontinued. So E is an instance of data table new row event args. E.row represents the row that's currently being added. I'm going to cast that to an instance of Northwind dataset.products row and then set discontinued to false. So let's set a breakpoint on each of these, and then let's run this code. So I'll run the application. I'm going to click data level data validation, and notice that even before the form appears, I'm in the products row changing event. If I click run, I'm in there again and again, because it turns out that when you populate a data table, the rows change. So this products row changing event is going to fire once for each of the 77 products in the table. So let me uncheck this now, finish filling out the form, and then come back and check it. It's an interesting thing about combo boxes and data tables is that events like selected index changed or row changed occur not only when you actually select an item from a combo box or modify data in a table, but also while you're filling them. So just keep that in mind. Okay, so let's validate the price. Let's enter -5. I'm going to tab off this, and that triggers the column changing event handler. E.column.column name is unit price. E.proposed value is what I entered, that's -5. And because the proposed value is less than or equal to 0, I'm going to set a column error on this row, and that will display in the form. And the reason it displays in the form is because I added to this form an error provider. I dragged that from the toolbox, and then I set its data source to products binding source. And that shows me this error. Now if I change this back to something greater than 0, then column changing runs again, And because now I've entered a valid price, I'm going to empty out that column error. Now notice if I change units in stock to 50, that also triggers the column changing. This event occurs when any column changes. So this gives me one place to do all of my column level validations. Let's test the row level rule. I'll set the price equal to 100 and the reorder level equal to 10,000. Now I'll try and save this. When I click the Save button, I'm going to call my Save Changes method, which is going to call my Validate Data method, which is going to call the Validate method of the form, and then call the End Edit method of the product's binding source. This commits pending changes, and that's going to trigger the product's row changing event handler on the product's data table. And at this point, I'm going to validate this rule, and since I've violated it, I'm going to set a row error on this row to this text. Now we'll step out of this. The end edit succeeds. Validate data returns true. And now I want to check to see if the form has any errors. So I'm going to call the data has errors method. And what this is going to do is call the has errors property of the products table, which is now set to true, because there is a row in this products table that has an error. Well, which row? I don't know yet, but we can find out. We can loop through each of the rows in the table, and if a row has errors, then we can grab the row error property of that row, and we're going to add it to the error string and display to the user that the following errors occurred. And therefore the data is not saved. Only if we set the valid price and a valid reordered level. Now we can save the changes. This will once again trigger row changing. But now at this point, there are no errors, so we're going to clear the errors off that row. And the changes have been saved. So one last thing, I'll click Add New to add a new products row. That triggers the Table New Row event handler. And here's where I set the default value for the discontinued column to false. So what you've seen in this demo is techniques you can use for validating data in the data set. And in the previous demo, you saw techniques you could use to validate at the form level. So you can decide when to validate at the form level and when to validate at the data level. Before we move on, I want to talk about local data. And so far we've been using server data in our demos. We could be using a SQL Server on another server on the network. We've been using SQL Server Express running locally, but regardless, we're working with the Northwind database that's been added to the SQL Server. There's another way you can work with data, and you can work with the individual data file, whether it's a SQL Server Express or an Access database file, and you can attach at runtime. So when you create the data source, you would choose either Access database file or SQL Server Express database file, and then go locate the SQL Server database or Access database file. When you do that, Visual Studio will ask you if you want to add the database file to the project. If you do, Visual Studio copies the database file into the project folder. And then, by default, Visual Studio will copy it from the project folder to the output folder every time you build the project. Well, this leads to a couple of things. First of all, you now have 3 versions of that database file on your hard drive. The original version, the version in the project folder, and the version in the output folder. And the other thing that happens is at runtime, your application will use the version of the file in the output folder. And the potential problem here is that you can overwrite data at development time, although not at runtime. And the reason is because Visual Studio by default copies that database file from the project folder to the output folder. So you build a form, you run it, you test it, you enter some data, you come back into design mode, you make changes to the form. The next time you build the form, Visual Studio overwrites the version of the database in the output folder with the version in the project folder. And therefore, the next time you run the application, you won't see the changes you made. And this can be confusing. Well, there's a couple things you can do about this. One is you can understand it and it's not a problem, and so leave the default. The other thing you can do is control what happens by using the copy to output directory property of that database file. So you'd select the database in the Solution Explorer and then make changes to the copy to output directory property in the Properties window. The default value for this property is copy always, and so the database file will be copied every time you build the application. Or you can set this to copy if newer, and then the database file will only be copied if the date modified property has changed. Typically, that will be if you made changes to the database, although apparently the date modified property can change even if you haven't touched it. And the third option is set this to do not copy, and then you're responsible for copying the database file if needed. The key here is to understand what's happening and then use the copy to output directory property in the way that meets your needs.